Imagine you are trying to figure out what most people in your neighborhood love to eat for dessert. You could ask everyone, right? But how do you make sense of all of these answers? That's where statistics comes in. It's like your personal data detective, helping you gather, organize, and analyze all the information to spot patterns and trends. With statistics, you can easily discover if most people love ice cream or if brownies are the hidden favorite. All about turning numbers and facts into useful insights, helping you make smarter decisions and understand the bigger picture. Hello guys, welcome back to Simply Learn's YouTube channel. And today I will walk you through the basic understanding of descriptive statistics, inferential statistics, frequency statistics, and kurtosis statistics, and more. Then I will take you through the differences among the various types. By the end of the video, you will know all you want to know about statistics and its types. Without any further delay, let's get into the video. First things first, let us understand what statistics actually is. Statistics is a branch of mathematics that help us collect, organize, and analyze data, understand patterns, trends, and make decisions. It's like having a big group of information and breaking it down to learn something useful. For example, if we survey 100 people about their favorite fruit, statistics help us figure out what most people like, what fruit is least liked, and how confident we are about these results here. After we have a basic idea of statistics, let us get into the various types of statistics. The first one is descriptive statistics. Descriptive statistics is a branch of statistics that focuses on summarizing and describing the main features of a dataset. This is further divided into measures of central tendency, measures of spread, and data distribution. Let's start with measures of central tendency, and this is further divided into three types. The first one is mean, the average of all data points. The second one is median, the middle value when data is arranged in order. The third one is mode, the most frequently occurring value. Let's break down the measures of central tendency, mean, median, and mode with an example. Imagine you have the following scores from a maths test taken by 7 students: 72, 85, 91, 89, 85, 76, and 90. Now you want to calculate the mean. Now, to calculate the mean, you have to add up all the scores and divide by the number of students. Therefore, the mean is 84. It means the average scores of the students is 84. Now, moving on to find the median. To find the median, we need to take the same example and we have to arrange the scores in ascending order. The median is the middle value, so in this case, the middle value is 85, since it is the fourth number in a list of 7. So, half of the students scored above 85 and half scored below 85. Now, moving on, the next is to calculate the mode. The mode is a score that appears most often. So, we take the same example and we see that 85 occurs twice more than any other score. So, the most common score in the test is 85. Just a quick info, guys, if you're really interested, unlock your data science career with Simply Learn's Data Scientist Master Program, ranked number 1 by Career Karma. In collaboration with IBM, this 11-month live online course teaches you top skills like Python, SQL, machine learning, and generative AI. With 25 plus hands-on projects, exclusive IBM hackathons, masterclasses, and job assistance, you will be ready to shine in the data science field. Don't miss out, enroll now and get ahead in your career. Now moving on to the next, that is the measures of spread. Unlike central tendency, which tells you whether the data is centered, spread tells you how scattered the data is. It has three components: range, variance, and standard deviation. Range, it is the difference between the highest and the lowest values in the set. And variance, it measures how much each score deviates from the mean. And standard deviation, it is the square root of variance. Let's use an example to understand measures of spread, range, variance, and standard deviation, which help us understand how spread out or dispersed the data is. Consider the test scores of 5 students. Now, we want to find the range. Therefore, the range is the difference between the highest and the lowest values in the dataset. That is, 85 minus 65 is equal to 20. The scores span a range of 20 points from 65 to 85. Now moving on, we want to find the variance for the same example. The variance measures how much each score deviates from the mean on average squared. First, we calculate the mean. So, to calculate the mean, we take the total of the scores divided by the total number of scores, and that is equal to 75. Next, we find the squared differences from the mean for each score. And here it is. 65 minus 75 whole square is equal to minus 10 whole square, and that is equal to 100. And in this way, we perform the same for each score. Now, the sum of these square differences divided by the number of data points is the variance. And that is taking the total of the squared differences divided by 5, that is equal to 50. The variance is 50, meaning that on average the square differences from the mean are 50. Now moving on to find the standard deviation. The standard deviation is the square root of the variance. It tells us how spread out the data is in the same units as the original data. The standard deviation is the root over of 50, that is approximately equal to 7.07. Now moving on, the third major subdivision is data distribution. Let us use an example to explain data distribution, which tells us how data points are spread or organized across a range of values. Imagine you have the following test scores for 20 students. One way to understand data distribution is by creating a histogram. The histogram groups the scores into ranges or bins and shows how many scores fall into each range. For this dataset, we could create bins like 50 to 60, there are 3 students, 61 to 70, there are 7 students, and 71 to 80, we have 5 students. And in this way, 81 to 90, we have 3 students, and 91 to 100, we have 2 students. Now, moving on to the normal distribution, the second one under the data distribution. In some cases, data follows a normal distribution which forms a bell-shaped curve, and this means most data points are around the mean with fewer data points as you move away from the mean in either direction. And normal distribution curve, it means most data points are around the mean with fewer data points as you move away from the mean in either direction. In a normal distribution, the mean, median, and mode are the same. Data is symmetrically spread around the center. Now moving on, in our example, the scores are somewhat concentrated around 70 to 80, but the distribution is not perfectly normal because there are more students scoring higher, that is the right skew. Therefore, skewed distribution, if a data set is not symmetrical, we have skewed distribution. And that is further divided into two. The right skew, that is the positive skew, and the left skew, that is the negative skew. In right skew, more data points are on the lower side with fewer higher values. And in the left skew, more data points are on the higher side with fewer low values. Moving on, in our test score example, we have a slightly right skew distribution because there are more students with lower scores, that is to 55 to 70, compared to higher scores, that is 90 to 100. And this is known as right skew distribution. Now, moving on to the second type of statistics, that is inferential statistics. It uses sample data to make predictions and generalizations about a larger population, allowing researchers to draw conclusions beyond the immediate dataset. Inferential statistics comprises several techniques for drawing conclusions. Here are some common types. Hypothesis testing. Second one is confidence intervals, and the third one is regression analysis. Now moving on to hypothesis testing. Hypothesis testing is a statistical method used to determine whether there is enough evidence in a sample of data to support a specific claim about a population. Let's work through the process of testing whether a new teaching method improves student test scores, breaking it down step by step with some explanations to make it easier to follow. Step number 1 is hypothesis. We always start by stating what we want to test. In this case, we want to see if the new teaching method helps students score better compared to the traditional one. To do this, we set up two hypotheses. H0, that is the null hypothesis, and that is the average test score with the new method is equal to 75. This means that the new method has no impact and there is no improvement in the test scores. H1, that is the alternative hypothesis, the average test score with the new method is greater than 75. This suggests that the new method does improve test scores. In simple terms, we are trying to figure out if the new method makes any difference compared to what we normally expect, which is a score of 75. Now, moving on to the next step, that is significance level. Next, we need to decide how confident we want to be in our conclusion. The significance level helps us measure this. It tells us the probability of mistakenly rejecting the null hypothesis when it's actually true. Type 1 error. A common choice for this significance level is 0.05 or 5%. This means we are willing to accept a 5% chance of making a mistake by rejecting the null hypothesis when it is true. So we said alpha is equal to 0.05. Step 3. Collect data. Now we need some actual data to test. Let's say we taught 30 students using the new method and their average test score came out to be 78. This is our sample data and we will compare it to the population mean, which is 75, the traditional method score. Now moving on to the next step, that is perform statistical test, the t-test. With the data in hand, we need to perform a statistical test. For this test, we will use a t-test which will help us compare the sample mean 78 to the population mean 75. The t-test checks if the difference between the two means is significant or if it could just be due to random chance. Moving on to the next step, that is the p-value. The p-value from the t-test is the number that tells us the probability of getting the sample data if the null hypothesis is true. Let's say the t-test gives us a p-value of 0.03. This means there is 3% chance of seeing this level of improvement if the new method doesn't actually improve scores. Now moving on to the last step, that is decision. Now we compare the p-value to our significant level alpha. If the p-value is smaller than 0.05, it means the results are statistically significant and we can reject the null hypothesis. In our case, the p-value is 0.03, which is less than 0.05. So we reject the null hypothesis. Now moving on to the second part, that is confidence interval. A confidence interval is a range that tells us how sure we are about an estimate from sample data. It gives a range of values whether the true member likely false. For example, suppose you survey 100 men in a city to estimate the average height. The average height from your sample is 175 centimeter and the standard deviation is 10 centimeter. You want to calculate 95% confidence interval to estimate the true average height of all men in the city. Now let's move on to the steps. Sample mean. The sample average is 175 centimeter. The standard error is calculated as 10 by root over of 100, that is equal to 1. Now, the confidence interval formula for a 95% confidence level use the critical value 1.96. The confidence interval is 175 plus minus 1.96 into 1. That is equal to 175 plus minus 1.96. The result, the 95% confidence interval is 173.04, 176.96. You can be 95% confident that the true average height of all men in the city is 173.04 centimeter and 176.96 centimeter. Now moving on to the third one, that is regression analysis. Regression analysis is a way to understand how one thing affects another. For example, if you own a shop and want to know if spending more on advertising increases your sales, you can use regression analysis. In this case, advertising spending is a thing you control, that is the independent variable, and sales is what you want to predict. By analyzing the past data, regression helps finding a pattern or relationship. For example, you might discover that for every $100 you spend on advertising, your sales increase by $200. This means you are positive relationship between advertising and sales. Now, if you plan to spend $500 on advertising, you can predict an increase in the sales by applying that relationship. Regression analysis gives you a formula or model to make such predictions based on the pattern you identified. In short, regression helps you logically predict how changes in one factor affect another. Next, I will be talking about is frequency statistics. In statistics, frequency refers to how often something occurs in a dataset. It simply counts how many times each value or event appears. Frequency is useful for understanding the distribution or pattern of data. Let's say you surveyed 10 people about their favorite food and the results were 4 people chose apples, 3 people chose bananas, 2 people chose oranges, and 1 person chose grapes. Here's how frequency works. Apples have a frequency of 4 as 4% chose it. Bananas have a frequency of 3, oranges have a frequency of 2, and grape has a frequency of 1. In this simple example, frequency helps you see that apples were the most popular fruit choice, while grapes were the least popular. Last but not the least, let's talk about Kurtosis Statistics. Kurtosis is a statistical term that describes the shape of the distribution of data, especially how the data is concentrated in the tails. It helps us understand if the data has more or fewer extreme values compared to a normal distribution. It is further divided into high kurtosis and low kurtosis. High kurtosis has more extreme values, and in low kurtosis, the data has fewer extreme values. In short, high kurtosis means more extreme heights, while low kurtosis means more consistent, evenly spread heights. By now, you must be curious to know about the differences among all the types of statistics. So here we go. Differentiating them on the basis of purpose. Descriptive statistics summarizes the main features of a dataset, for example, mean, median, and standard deviation. Inferential statistics makes predictions or generalizations about a population based on sample data. Frequency statistics counts when specific values or events occur in the dataset. Kurtosis describes the shape of the distribution, focusing on the tails and extreme values, differentiating them on the basis of data focus. Descriptive statistics deals with the entire dataset at hand. Inferential statistics uses a sample to infer conclusions about a larger population. Statistics focuses on the frequency of individual values or categories. Kurtosis focuses on whether the data has many or few extreme values. Now differentiating them on the basis of common metrics. In descriptive statistics is the mean, median, mode, and standard deviation and range. In inferential statistics, it is hypothesis testing, confidential intervals, regression analysis. In statistics, it is frequency counts, frequency tables, histograms, bars, and charts. In kurtosis value, high kurtosis is equal to more extreme values and low kurtosis is equal to fewer extremes. Now, differentiating on the basis of complexity. Complexity in descriptive statistics is simple and straightforward, summarizes the observed data, and in inferential statistics it is more complex, and in statistics it is simple counting and displaying of occurrences. Kurtosis requires statistical analysis to determine the distribution's tailedness. Now finally, differentiating them on the basis of visualization. Descriptive statistics, it is the box plots, pie charts, and summary tables. Inferential statistics, it is confidence intervals, regression lines, p-values, and more. And in statistics, it is bar charts, histograms, frequency tables. And kurtosis, it is histograms, distribution plots to visualize outliers. So here is a question for you guys. I hope everyone will comment your answers in the chat section and let's see how many of you really understood the topic. So the question is, which of the following is not a measure of central tendency? And the options are mean, median, mode, and standard deviation. Participate in the quiz and I hope to see your answers in the comment section. We will reply to whoever provides the correct answer and the wrong answers will be corrected for sure. I will provide you 1 minute to write your answers in the comment section. So guys, that's a wrap up. I hope you have liked the video. If you have any questions, do comment and one of our experts will definitely get back to you. Do like and subscribe to the channel for more updates like this. I will see you in the next video. Till then, keep learning with Simply Learn. Thank you for watching.
Hi there, if you like this video, subscribe to the Simply Learn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.